This is Design Safe Radio, where natural hazards researchers strive to make our society more resilient to everything nature throws at us.
Yeah, it's always interesting when you look at laboratory conditions versus field conditions. I'm kind of going back to the biosphere here, because it was just a few weeks ago that I was out there with the National Science Foundation group. But they're growing trees indoors in desert conditions and rainforest conditions, but there's no wind, and so the trees are growing larger and larger. And because they haven't been subjected to wind stresses, their trunks are very weak, and their root structures are very weak.
Oh, wow. Yeah, that makes sense. That's interesting.
Yeah. And so it was like, oh, I want thinking from biological perspective, but also engineering perspective, like how can we learn from that of how plants and trees grow to need to have those kinds of root structures and trunk structures by being stressed repeatedly. It's really interesting.
It's almost like a muscle, right? If you work your muscle, then it gets really strong because it gets that stimulus.
Yeah, it was always really interesting. Just hearing of this intersection of engineering and nature. We were talking a little bit before got on that tree looks like one across the street from our house. So it's every time I'm just walking around, and anybody who's listening to this, you can see there's not such a distinct line between nature out there and our built environment. Like as humans, we are part of the natural environment. And so if you're a scientist and engineer listening to this and hopefully inspired by Alejandro, you start to be more observant about just simple things like vines on a wall and how they grow and why they're there and how they get to stay there year after year, no matter how much you treat them.
Yeah, right. How they come back and they keep coming back. Yeah, it's really nice once you sort of start thinking about it that way. If you go out on a hike and you just start observing everything around you, you just sort of, there's just so many ideas and so many things out there.
Yeah, that might be actually really fun. Like next time I'm down in Davis, we could go on an engineering hike and
Let's
do some measurements, do some drawing, look at soil conditions and what's growing and root structures. I think that'd be pretty fun.
That would be awesome. That'd be amazing.
Anybody who wants to join, let us know. What's next for you, and where can we follow along with your research team and what you guys are up to?
Yeah, so right now we're doing a lot of work with the Snakeskin inspired foundations, and so we've done work in the laboratory where we've done numerical work, simulations, we've done centrifuge work, and sort of. And the centrifuge has been really helpful in sort of translating what we've learned into conditions closer to the field. And so we have done an initial field trial. We did it about 18 months ago, also on campus. And so actually the CGM staff helped us deploy snakeskin inspired anchors out in the field, and they performed really well. The behavior was, in a way, even better than we were expecting, and so we've shown that the concept works and that we can develop more efficient foundations, anchors, and all that stuff. But in the real world, it's not all about efficiency and increased capacity. There's all the sort of real world considerations like cost, right?
Yeah.
If they were great, but they cost 10 times more than traditional solutions, then it's going to be harder to install those. Then all of a sudden they're not that efficient. And so the process that we're on right now is we've partnered with an industry company, a geotechnical contractor, and sort of the specific goal of what we're doing is to modify the designs that we've developed such that we can use materials that are readily available, so that they can be installed in a fast manner. The cost can be decreased so that it can be competitive with current solutions, and also just to test in a different, look for different applications, different soil types, different conditions. we did, we've looked at, in a way, idealized soil profiles, so sort of a uniform sand or uniform clay, but we haven't done so much with very variable soils or soils that can be a bit more problematic. And so that's the next step to sort of facilitate that transition to industry, make it more sort of affordable, but also integrated with construction techniques that are used every day in the field. And another thing would be to develop design procedures for predicting the capacity and the performance of these types of foundations. And so one sort of avenue is translating this into practice. Another avenue we're looking into is we've been working with a company that designs and installs offshore wind turbines, like I have here on my screen. And they're also interested on applying the snakeskin pattern on offshore foundations.
Oh, wow.
So we're also looking in other applications in other areas for that type of work. And the other area that I mentioned with the site characterization in sites that are difficult to access, we're in a way going through a similar process where we've done a lot of the initial legwork, the fundamental research to understand what conditions lead to better improvements and that sort of stuff. And now we're also partnering and getting feedback from companies to be able to produce this equipment that then they can use for characterized sites and that sort of stuff. That in a way is sort of at the core of the Engineering Research Center, the ERC, the type of center that CBBG is to develop, very nice fundamental research, develop technology, but then take it all the way to sort of industry adoption. And in a lot of our projects, that's the stage that we are on right now.
Beautiful. Well, as always, it's been really, really fun to hear what you and the UC Davis Center are up to, and the CBBG group. Like every time I hear someone from that research group, it's like, you're doing what? This is so cool. Thanks for taking time out of your evening and your sabbatical, and really appreciate it. And looking forward to when you're back in the States and get to come down to Davis and hang out in person. That'd be great.
Yeah, and do that engineering hike.
Yeah, I'm going to send you a link here once we stop recording to something that would be really fun to do.
All right, that sounds great. Thanks for having me.
Yeah, you're welcome. Have a great day.
Yeah, thanks.
Thanks for listening to today's episode of Design Safe Radio. Be sure to like and subscribe on whatever platform you happen to be listening to this on. It really helps people find our show. Thanks to our amazing sponsors, the National Science Foundation and the NHERI Network Coordination Office, which is award number 2129782. Big thank you to Marty LaChance, our guest booker and topic researcher extraordinaire, and Raquel Ruiz, who is our video and audio editor. I'm your host and NHERI Facility Scheduling and Operations Coordinator, Dan Zahner. We'll see you in the next episode. Until then, stay resilient.